Hello students, I am going to explain the basics of probability. The first term is experiments or models. We all are very well known with the term experiments. We performed the experiments in physics, chemistry, biology. In statistics, the experiments is not necessarily restricted to laboratories experiments. In statistics, we can predict all possible outcomes of experiments on the basis of only logical reasoning without conducting the experiments. Experiments is virtually any operation that results in one or more outcomes. For example, tossing a coin is an experiment with two possible outcomes. Head will turn up or tail will turn up. The second example is throwing a six-faced die with possible outcomes are 1, 2, 3, 4, 5, 6. These are the 6 possible outcomes of the experiment. The next example is releasing a stone from hand with possible outcome is it fall on the ground. These are the some examples of the experiments or models. Now we see the second term, that is trial of an experiment. Trial of an experiment. The trial of an experiment is nothing but the experiment is performed once. So, n trial experiments means that we perform experiments n times, either sequentially or simultaneously. The experiments are classified into two categories. The first type is deterministic experiment. Deterministic experiments. And second type is non-deterministic experiments. Non-deterministic experiments. Now we see first type of the experiments, that is deterministic type of experiments. This type of experiments has a unique outcome, hence it is certain. The outcome of this type of experiments can be predicted in advance before conducting the experiments. In other words, the deterministic type experiments are predictable phenomena. For example, throwing a ball in the sky, the outcome will be it fall on the ground. Second example is cooling water below 0 degrees Celsius. the outcome of these experiments will be freeze or ice. These are the examples of the deterministic type experiments. Now, second type of experiments is non-deterministic experiments, or it is also called as random experiments. This type of experiment has more than one possible outcomes, and its all possible outcomes can be predicted in advance before conducting the experiments. However, its certain outcome cannot be predicted in advance before conducting the experiments. For example, tossing a coin with possible outcomes are head will turn up or tail will turn up. The second example is throwing a six-faced die with possible outcomes are 1, 2, 3, 4, 5, 6. These are the possible outcomes. Then we are interested only in non-deterministic type experiments because this type of experiments has more than one possible outcomes. So we can play with this type of experiments only. We can't play with deterministic type experiments because it has unique outcome. So we cannot play with deterministic type experiments. Now, statistical regularity. Now first we see the concept of statistical regularity. Though we cannot predict the outcome of a single trial of the experiments, however, we can get some knowledge about the pattern among the outcomes when experiments is performed repeatedly large number of times. For example, we can't say whether head will turn up or tail will turn up if a fair coin is tossed. However, if the coin is tossed 1000 times, then what we will expect? This is the question. If the coin is tossed 1000 times, in this case, we will expect that about 500 times tail will turn up or about 500 times head will turn up. If the number of tosses increased, in that case, we expect that the proportion of getting head should approach to value 1/2. Thus, the proportion of getting head approach to the value 0.5 as the number of tosses increases. Thus, though the outcome of any particular type of experiment may be uncertain, in that case, there exists a long-term regularity. And this is the basis for development of the random experiments, or it is also called as the probabilistic models. Means in statistical regularity, if we perform experiments large number of times, in that case there exists a long-term regularity. Okay. Now, sample space. Definition of sample space is a set of all possible outcomes of any random experiments is called as sample space. Sample space is denoted by the letter, this is Greek letter omega, or this S. These two notations are used to denote the sample space. Generally, sample space can be written as omega is equal to omega 1, omega 2, omega 3, so on, omega n. Here, the small omega 1, omega 2, omega 3 and omega n, these are the sample points in the sample space omega. Now, we see first example. For that example, we have to write the sample space. Consider the experiment of tossing two coins simultaneously. Then, for this experiment, the sample space is omega is equal to, write in curly bracket, H T TH and TT. The sample space contains 4 outcomes. If we toss two coins simultaneously, HH, HT, TH and TT. This sample space contains finite number of outcomes. Okay. Now, the second example is tossing a coin until head appears. Sample space for this experiment is omega is equal to H, then TH, TT, H, TT, T, H and so on. In this sample space contains countably infinite number of outcomes. And third example is, consider the experiment of measuring height of a person. In this case, we consider lowest height and highest height of a person. The lowest height of person is 130 centimeter and highest height of a person is 190 centimeter. Then we have a interval 130 to 190, and in this interval there are uncountably infinite number of outcomes. These are the 3 examples of sample space. First one is, this sample space contains finite number of elements. In second sample space there are countably infinite number of elements, and in third sample space there are uncountably infinite number of elements. The first type is called as the finite sample space, the second type is the countably infinite sample space, and third type is the uncountably infinite sample space. This is the concept of sample space. Now we see types of the sample space. First type is discrete sample space. Number 1, sample pace. And second type is continuous sample pace. Continuous sample pace. Now first we see discrete sample pace. If sample pace contains finite number of elements or countably infinite number of elements, then the sample pace is called as the discrete sample pace. And continuous sample pace means if sample pace contains uncountably infinite number of elements, then the sample pace is called as the continuous sample pace. The first two examples of discrete type sample pace and the third example is of the continuous type sample pace. This sample pace and the other types, discrete sample pace and continuous sample pace. Now the next term is events. The definition of event is events. Events means a subset of sample pace omega is called as event. Now consider the experiment of throwing a die. Then the sample pace for this experiment is omega is equal to 1, 2, 3, 4, 5, 6. This is the sample pace corresponding to the throwing a 6-faced die. On the sample pace, event A is defined. Event A is such that an odd number occurs. An odd number occurs. Then event A contains the outcomes A is equal to 1, 3, 5. Here A is the subset of omega. A is subset of sample pace omega, therefore A is an event. Okay, this is the definition of event. Now we see types of events. First type of event is simple event. Simple event, or it is also called as elementary events. If event contains only one outcome, then the event is called as the simple event or elementary event. For example, consider the experiment of tossing a coin. Then sample pace is omega is equal to h and t. On this sample pace, event A is defined. A is equal to head occurs. Head occurs. Then event A contains the outcome only H. Therefore, the A is called as simple event or elementary event. Now, second type is compound event. Second type is compound event. If event contains all possible outcomes of sample space omega, then it is called as the compound events. For example, suppose omega is equal to 1, 2, 3, 4, 5, 6. On this sample space, event A is defined as equal to natural number occurs. Natural number occurs. Then A contains the outcomes 1, 2, 3, 4, 5, 6. So this event is called as the compound event. If event contains all possible outcomes of the sample space omega, then the event is called as the compound event. Next type is impossible event. Impossible event. Impossible event. Definition is an empty set is called an impossible event, or if event does not contain any outcome, then the event is called as the impossible event. For example, suppose omega is equal to H and T. On this sample space, event A is defined, that is exactly 2 heads occurs. Exactly 2 heads occur. Then A is equal to an empty set. The event A does not contain any outcome, so it is called as the impossible event.